Indian Olympiad Qualifier in Mathematics.
So pause చేస్తారు.
So IOQM stands for Indian Olympiad Qualifier in Mathematics. So the students, those who want to participate in the IOQM, they can register through the exam through their official website, okay? And the exam is going to be conducted in the September. And the exam is having the 3 stages. So coming to the first stage, it is of the IOQM, and then after we are having the RMO, and then after we are having the third stage, which is nothing but our INMO, okay? So coming to the 3 different stages, first stage we are having the qualifying mark different for each session, okay? So now coming to the exam pattern is, now the exam is for 100 marks. So coming to here, we are having, so coming to the exam pattern, the exam is for 100 marks and we are having the 2 marks question, 10 2 marks questions, and then after we are having the 3 marks questions and the 5 marks questions, okay? So moving to the next, we will discuss about what are the topics. That means we are having the different topics for our IOQM. So starting with our basic maths, then after number theory, then after algebra, and then after combinatorics, and then after it is the geometry, okay? So as we are not having so much time to prepare for all the topics, we are going to start with our geometry, okay? So coming to the geometry further, it is classified as Euclidean geometry and trigonometry, and next coordinate geometry and the geometric transformations. So coming to the Euclid geometry is your basic of the grade 9 and 8, which is of your elements of Euclid, elements like point, line, plane or surface, and then after we will discuss about the circles and the theorems related to the circles, and then after we are having the polygons, okay? So as you know about the quadrilaterals and polygons are same. But coming to the polygons, we will discuss what is the sum of the interior angles and what is the sum of the exterior angles. Moving to the next trigonometry part. So coming to the trigonometry part, first of all we will discuss about what are the trigonometric ratios, and then after we will discuss about what are the trigonometric identities, okay? And next we will discuss about the applications of trigonometry. Moving to the next is your coordinate geometry. So coming to the coordinate geometry, we are having very favorite subject, that is the coordinate geometry, because up to the grade 9 we are having only the plotting of points. But coming to the coordinate geometry, we will discuss about the distance formula, section formula, and slope and equation of line, and then after we will discuss about the conic section, which consists of your parabola, ellipse and hyperbola. So moving to the last part of the coordinate geometry is nothing but your geometric transformations, which is like your logical reasoning, I can say, because there you can find your the topics like reflection, rotation, translation, and then after isometries and symmetry and tessellations. So these topics we know about, because reflection and rotation we know, because coming to the symmetry parts, what we discussed in the grade 5 symmetry, that is your reflection symmetry and mirror symmetry and the rotation, that all will comes under the reflection, rotation and translation part, okay? So coming to the geometry, first we will start with the Euclidean geometry. So coming to the Euclidean geometry, firstly we will discuss about the points, lines, and then after plane. So we know that elements of Euclidean geometry is nothing but your points, lines and plane. Point is just a dot which is not having any dimensions. So we can say that point is the dimensionless, okay? Now consider that I am having a point here, okay? So I am having a point here, this is my point. So how can we represent the point? Means we can represent it with the help of a capital letter. But if I am taking the collection of those points and if I join them, it will give us line, okay? So now we can define a line, we can say that line is the nothing but the collection of the points, okay? So now coming to here, lines can be represented with the help of the letters. So in the lines also we are having the different types like our line segment and ray. So coming to the line is nothing but which can be extended from both the ends, okay, where it is not having any end point. But coming to the line, we can get a line from the line segment. How means, if I am considering this is my line and if I am taking a part from this, okay, with the points of A and B, then it becomes your line segment, okay. Now, just consider that this is my arrow mark, it represents the end point C. Now, if I am taking my point part of the line from A to B, it will become the line. But what if I am taking from B to C? That becomes your ray, okay, where we can say that the line is having the two endpoints, where the ray is having only one endpoint and another endpoint can be extended. So coming to the plane, plane is nothing but the collection of lines. That means if I am taking my lines like this and if I am just joining them, then I will get my plane, okay. Now coming to the dimensions of line is nothing but, if you observe, we are just going to draw a line like this which is having only length, okay. So now we can say that a line is a breadthless length. Now if we observe, we are having the line and which is having only the one dimension, which is nothing but your length. So we can say that line is the one dimension, okay. Whereas moving to the plane or surface, if you observe here, we are getting the two dimensions which is nothing but your length and breadth. So it is of two dimensional, okay. So now moving to the next, we will discuss about the types of angles in the Euclidean geometry. So coming to the types of angles, we are going to take our reference angle as the 90 degrees, okay. So which we are going to call it as the right angle, which is having the measure of 90 degrees, okay. Now if I am having an angle which is less than 90, we are going to call them as the acute angle. And if we are having an angle, so after the 90 degrees, we can take a reference angle, that is your line, okay. Now the angle of your straight line will become 180 degrees. So now 180 degrees is called straight angle. So now if I am having an angle in between the 90 and 180, we are going to call it as the obtuse angle, okay. So now moving to the next, it is of the reflex angle. Reflex angle is nothing but, if I am considering a point here and if I am starting from here and if I am completing the one revolution, then if we look at here, it is completing a circle, okay. So now here it is forming an angle of 360 degrees. So now we are going to call the 360 degrees as the complete angle, okay. So now coming to here, if we are having the angle between greater than 180 but less than 360, we are going to call it as the reflex angle. And if that angle is equals to 360 degrees, then it forms the complete angle, okay. So now let's discuss what are the angles formed by the straight lines and a transversal. So as we know that we are having the parallel lines which do not intersect each other. So consider that I am having my line L, okay, and I am having my line M. If we observe here, whatever the distance we are having, just consider this is my point A and this is my point B, okay, and this is my point C and this is my point D, okay. Now whatever the distance we are having between these two lines at the point A and B, we are going to have the same distance at the C and D also, okay, and they are not going to intersect at any point. Those lines are called as parallel lines, okay. Moving to the next, if I am having a two lines, they are going to cross each other, then we are going to call them as the intersecting lines. Now if we discuss here, we are going to take the two lines, okay, and we are having a line which is cutting, and that means which is intersecting both the lines. We are going to call it as the transversal. Now let's see what are the angles formed by the transversal. Yes, if you look at here, we are having the angle 1, and if you observe here, we are having angle 1, angle 4, angle 7 and angle 6 outside of these two lines. So we are going to call them as the exterior angles. And if we observe angle 3, angle 2, angle 8 and angle 5, we are having those angles lie inside of those two lines. So they becomes the interior angles. So these are the interior angles, whereas coming to the remaining angles will form the exterior angles, okay. So now if I am considering my angle 1 angle 4, angle 7 and angle 6. Here it becomes angle 1, angle 4, angle 6 and angle 7. Now, if I am taking the opposite angle for my angle 7, which are the exterior angles, those two will form alternate exterior. Okay. So, from these we can write the condition that alternate exterior angles are equal. Okay. So, here we can write alternate exterior angles are equal. So, now from there we will get angle 1 equals to angle 7 and angle 2 equals to angle 6. Okay. In the same way we can apply the alternate interior angles also. From there you will get your angle 3 equals to angle 5 and angle 2 equals to angle 8. Understood? So, in the same way we are having the corresponding angles, which is nothing but one of your interior and one of your exterior. That means our 4 will be equals to the our 8 and angle 3 will be equals to the angle 7. And moving to the other side of the transversal, we are having angle 1 equals to angle 5 and angle 2 equals to angle 6, as they are forming the corresponding angles. Now, let's observe about the co-interior. So, co-interior is nothing but if you take one of the side of the transversal, we can observe that we are having the angle 2 and angle 5 on the right side of the transversal. Now, they will form the co-interior angles and some of the co-interior angles will be equals to the 180 degrees. Understood? So, here we are having the co-interior angles which are nothing but your angle 2, angle 5 will form one pair of co-interior and angle 3 and angle 8 will form another pair of co-interior. So, from there you will get angle 2 plus angle 5 will be equals to 180 and angle 3 plus angle 8 will be equals to 180. Now, let's discuss about the another part of the Euclidean geometry, that is nothing but your triangles. So, we know that we are having a triangle. Okay. So, now just consider the vertices are A, B, C. Now, coming to the triangles, we are having the different types of triangles depending upon the sides and depending upon the angles. If you are having all sides are equal, that means all sides are equal, then it becomes the equilateral triangle. Okay. And if you are having two sides are equal, so that means two sides are equal, then it becomes the isosceles. And if you are having no sides are equal, that means three sides are different, then it become scalene. Okay. So, moving to the next, depending upon the angles, if I am having all my three angles are acute angles, then it becomes the acute angled triangle. Okay. And if I am having one of my angle in a triangle is the 90 degrees, then it becomes the right angled triangle. Okay. Now, let's see what about the symmetry and congruency of the triangles. So, now if you observe here, we are having the triangle ABC and triangle PQR. But if you observe here carefully, if I overlap my triangle PQR on the triangle ABC, I will get that exactly it is going to overlap with the ABC. Okay. So, now we can say that the triangle ABC and PQR are congruent. But if you observe in the second figure, these two triangles are having the same shape. But if I overlap, one is the enlargement of the ABC. So, these are going to form the similarity. Okay. So, we are going to say that the figures are congruent if they are having the same shape and same size. And we are going to say that the shapes are similar if they are having only the same shape. Okay. So, now let's see what are the criteria we are going to use in order to say that the triangles are congruent and similar. So, now if you are saying that the triangles are congruent means we are having the corresponding sides are equal and corresponding angles are equal. Corresponding sides are equal is nothing but if I am overlapping my ABC with the PQR, whatever the side of the PQR falls on the side of the AB, then we are going to say that those are the corresponding sides. Okay. Just assume that I am having my triangle ABC. So, just consider that I am having my triangle ABC. So, this is the symbol we are going to use in order to represent the congruency between the two triangles. So, triangle PQR congruent to triangle PQR. Okay. So, that means what? If I overlap my PQR on the ABC, the vertex P falls on the vertex A. and Q falls on the B and R falls on the C. So from these conditions we can write that corresponding angles are equal and corresponding sides are equal in the congruent figures. That means corresponding angles will become angle A will be equals to angle P. Okay, and moving to the next, angle B will be equals to angle Q and angle C will be equals to angle R. Understood? So now sometimes in the given question, whatever the order of the vertices of the triangle will help us to find what are the corresponding angles and the corresponding sides. Now coming to the corresponding sides, it will become AB equals to PQ and BC equals to QR and CA equals to RP. Okay. So now from this we can say that what are the corresponding angles and corresponding sides of the two triangles. So now moving to the next, we will learn what are the criteria in order to say that the given triangles are congruent. Okay. So now, criteria are mostly dependent upon the angles and the sides that are given for us. Okay. Just assume that we are having a question in which two of the sides of the two triangles are given and one of the angle are given. Then at that time we can use the criteria for the congruency in order to say whether the given triangles are congruent or not. So what are those criteria means? So we are having the criteria starting with sides. I am saying that all corresponding sides are equal for the congruency. That means if I am having my side which is nothing but your AB equals to PQ and next BC will be equals to QR and next CA equals to RP. Okay. If I am having my three sides of a one triangle equals to the three sides corresponding sides of another triangle, then we can use side criteria for the congruency. Okay. So now moving to the next, if I am having an angle and if I am having my two sides are equal and the corresponding angle, that means if the angle is included between the sides that are equal, then we can use the side angle side. Moving to the next, we are having angle side angle. So moving to the next, we are having angle side angle. Okay. Yes. So moving to the next, we are having angle side angle. And once again we are having angle side. Okay. Now in the same way we can apply the criteria for the right angle triangle also. That is nothing but your RHS criteria. So now moving to the next, similarity of triangles. So in congruency you are having corresponding angles are equal and corresponding sides are equal. But coming to the similarity, you are having the corresponding angles are equal but corresponding sides are proportional. Okay. So now if you look at here, corresponding angles are equal. That means you will get your angle A equals to angle P and angle B equals to angle Q and angle C equals to angle R. Okay. Now the corresponding sides are proportional means just consider that the side PQ falls on AB. So now the ratio of AB by PQ will be equals to BC by QR will be equals to CA by RP. Okay. So here I can take the direct condition of sides are equal, but here we are going to take the ratio of these sides are equal. That means the sides are in the proportion. Okay. Let's see what are the criteria we can apply for the similarity. So coming to the similarity criteria, we are having the angle because we are having the corresponding angles are equal. Then after we are having the side angle side, and then after we are having angle side angle. Okay. And then after angle side. Okay. So if you observe here carefully, we are not having the angle criteria for the for the congruency of triangles. Okay. And if you observe here, we are not having the side criteria for the similarity. Why? Because if I am considering my triangle with the three corresponding sides are equal, there may be a chance of getting the angles as different. Okay. And if you observe here, we can have the angles of the triangles are equal, but if you observe here, triangle PQR is nothing but enlargement of the ABC. That means whatever the angle you are having at A can be an angle P. Okay. And your angle at B can be equals to the angle Q. And angle C will be equals to the angle R. But if you observe clearly, we can say that AB is not equals to PQ. Okay, that's the reason we are not going to use the side criteria for the similarity of triangles. And at the same time, we are not going to use the angle criteria. Otherwise, we can say it as angle criteria. Okay, if two angles are equal in a triangle, so however we will get the third angle also equal by the angle sum property of the triangle. Okay, so now let's discuss the two basic theorems that required for the IOQM up to the grade 10. So that is of nothing but your midpoint theorem. Okay, and next one is the basic proportionality theorem. Okay, so coming to the midpoint theorem is, if I am having my P is the midpoint of AB and Q is the midpoint of AC. Okay, now PQ is the line joining the two midpoints of two sides of a triangle. Now the line will be parallel to the third side and this is equals to half of the BC. Okay, so coming to the midpoint theorem, we can say that P is midpoint of AB and Q is midpoint of AC. So now if you observe here, we are having a line PQ which is joining the two midpoints. So now from this you will get PQ parallel to BC and the PQ equals to half of BC. Okay, so from this we can say that if you observe here, we can write the, we can rearrange the theorem also. Okay, that is nothing but, if they give that the line is parallel to the BC means you can apply your PQ equals to half of BC. And if they give that PQ is half of BC means you can consider that PQ will be parallel to the BC. Okay, now coming to the basic proportionality theorem. So I am having my PQ the same. Okay, now P will divide AB into the two parts, that is your AP and BP, and Q will divide your AC into the two parts, that is your AQ and QC. Now the parts will be in proportion, that means here you will get AP by PB equals to AQ by QC. Okay, now you can rearrange these terms and you can get the different forms of the basic proportionality theorem. Okay, so now these can be written as, once again, AP by the complete side AB which will be equals to AQ by the complete side AC. Understood? Yes. So now moving to the next, we will discuss about the polygons. So polygons are nothing but the closed figures that are formed by the straight lines. So coming to here, if I am considering the two lines. So if I am considering my two lines, it is not forming a closed shape. Of course it is having a straight lines, but it is not forming a closed shape. So coming to the minimum number of sides that required to form a closed shape is nothing but your 3 sides. Okay, and the name that can be formed is triangle. So coming to here, we will require the minimum of 3 sides to form a polygon, and the basic polygon is nothing but your triangle. Okay, so coming to here, we are having the sum of interior angles of a polygon. Sum of interior angles of a polygon, which is given by n minus 2 into 180. Okay, where n is nothing but your number of sides of a polygon. Okay, so now if you consider here for a triangle, what will be the number of sides will become 3. So it will become 180 into 3 minus 2, which will give you 180 into 1. So which is nothing but your sum of interior angles will become 180 degrees. Okay, sum of interior angles means here if you consider here, we are having the 3 angles inside the triangle. Okay, and if you take the sum of those 3 angles, you will get the value equals to 180 degrees. Now moving to the next, sum of exterior angles. So sum of exterior angles. So how the exterior angles can be formed for a polygon means, just consider that this is my A, B and C. Okay, if I am extending my BC and if I am extending my AC and if I am extending my AB, I will get my 3 of the exterior angles. So these 3 will form the exterior angles, and if you take the sum of those three, we will get sum of exterior angles will be equals to the 360 degrees. Okay. You can apply this sum of three exterior angles or sum of exterior angles for any polygon. Like if you are having a quadrilateral, that means it is having the four sides. So if you take the exterior angles, sum of exterior angles means it will be equals to 360. Okay. So now coming to the quadrilaterals, it is nothing but if we are having a polygon that is formed by the four sides, then we are going to call it as a quadrilateral. Okay. Quad in the sense 4. So now it is a polygon I am saying, that means it will be a closed shape. If we are having a closed shape formed by the four sides, then we are going to call it as the quadrilateral. Now the quadrilaterals are further simplified as trapezium or trapezoid, and next it is the parallelogram and the kite. So coming to the trapezium is nothing but, if you observe here, we are having the one pair of sides of a quadrilateral are the parallel. Okay. So that means just consider here you are having A, B, C and D. And coming to here you are having your side AB is parallel to CD. That means here we are having one pair of sides are parallel. And trapezium is further can be given as isosceles trapezoid. When means if you observe here these two are the non-parallel sides. That means AC and BD are the non-parallel sides. If I am having the length of the non-parallel sides are equal, that means here if you observe we are having those two sides are equal. So then we will get the isosceles trapezoid. Okay. So isosceles trapezoid can be formed from the trapezoid by making the non-parallel sides as equal. So coming to the parallelogram, if you observe here we are having the two pair of sides are parallel. So that is nothing but your AB, CD. So now here we can observe that AB is parallel to CD and at the same time our side AD is parallel to the BC. Okay. So parallelogram is having the two pairs of parallel sides. Moving to the next, kite. So coming to the kite is nothing but if you are having your adjacent sides are equal for a quadrilateral, then it is going to form a kite. Okay. So that means consider the vertices ABCD. So here I am having my AB equals to AD and BC equals to CD. Moving to the next, parallelogram is further classified as the rectangle. So how can we get the rectangle from the parallelogram means, if you are making the opposite sides of a parallelogram as equal, then we will get the rectangle. Okay. And if you are making the all sides of a parallelogram are equal, then it will be your rhombus. Now if you take the combination of the rhombus and rectangle, you will get your square. That means for a parallelogram, if you are making all sides are equal and if you are making all angles are equals to 90 degrees, then it forms a square. So for the rectangle you are having opposite sides are equal and the all interior angles will be equals to 90 degrees. Okay. So now if you take the combination of the rhombus and rectangle, that means all sides are equal from the rhombus and all angles are 90 degrees from the rectangle, then we will get a square. So moving further, we will discuss about the circles. So coming to here, circle, we know that that is nothing but a collection of points. Okay. So now coming to here, so for a circle we are having the center and radius. Radius, as you know that center, the distance from the center to the any point on the circle. So moving to the next, we will discuss about the theorems related to the circles. Those are nothing but you are having the circles chapter in your NCERT textbook in your grade 9. There you can see that we are having the circles theorems. Mostly we will discuss about the 5 of them. And coming to your grade 10, you are having the tangents and secants to a circle and the theorems related to the tangents and secants. Now, if we observe here, for a circle we are having a chord and a tangent. So when we can say that we are having a chord and tangent means, consider that you are having a circle. Okay. Now, if we are having a point, if you are having a line that touches the circle at one point, then we are going to call it as the tangent. Okay. And moving to the next, if I am bringing that line from top of the circle to the middle of the circle, then it will be touching the circle at the 2 points. Now it will become your secant. Okay. And if I am removing the exterior part of this line, and if you are having line inside the circle, then it is going to form the chord. Okay. Now we are having the theorems related to the circles depending upon the chord, okay, and depending upon the angle subtended by the chord. So consider that if you are having a circle and if you are having the two chords of a circle, so that means if I am having a circle and I am having my two chords, okay, so now I am having a circle with center O, AB is the one of the chord and CD is the another chord. Now I am joining my O with A and O with B and O with C and O with D, okay. Now angle AOB is the angle subtended by chord AB and COD is the angle subtended by chord CD at the center O. So now what it will become, if equal chords are there for a circle, then they will subtend the equal angles at the center. So from the theorem 1 we can write angle AOB equals to angle COD, okay. Moving to the next, we can look at here. So here we are having the angle at the center. So how means, just consider that we are having a circle and this is the center and this is the chord AB. Now I am going to draw a perpendicular from the center to the AB, okay. Now this perpendicular will divide my chord, that means it bisects the chord into the two equal parts, okay. That is your theorem 2. Now moving to the next, if you are having a circle and the chord, okay, so now I am having my, so if you observe here, here it is the center O, understood. Now if you take your chord of your circle, it will divide the circle into the two parts, that is your segment, that is nothing but which is having the larger area will become your major segment and which is having the smaller area will become minor segment. So now if you look at here, AB is forming an angle ACB in the one of the segment and the same AB is going to form the angle AOB at the center. Now angle at the center will be the 2 times of the angle in the remaining part of the circle, okay. So that means our angle AOB will be equals to the 2 times of ACB. So that means here if I am considering ACB as alpha, then my AOB will become 2 alpha, okay. So now moving to the next one is, so by this property we can get the angle in the semicircle. So that is nothing but just consider this is my angle in the semicircle, okay. And now here if you observe here, we are having angle at the center is 180 degrees. Now how we got 180 degrees? We got 180 degrees by 2 times of alpha. So I am going to take my 2 times of alpha equals to 180. So then alpha equals to 2 will cancel 180 for 90 times, okay. So that means I got my angle in the semicircle as the 90 degrees, okay. Now moving to the next, angles in the same segment. So if you observe here, so I am going to take the circle and the chord, okay. Now I am taking my 2 different angles in the same circle, okay. So now this is my A, B and C and D, understood. So now I am having my angle ACB in the same segment and angle ADB is also in the same segment. Then angles in the same segment are equal. That is your next theorem, okay. So now moving to the next, that is of your tangents and secant. So coming to the theorems related to the tangent and secant is nothing but if you are having tangents from external point to the external point to the circle means those tangents are equal, okay. And moving to the next, perpendicular from center to the tangent, if you draw a line from center to the tangent, now it is perpendicular to the tangent, okay. And moving to the next is your cyclic quadrilateral. Cyclic quadrilateral is nothing but if we are having the 4 vertices of a quadrilateral on the circle, then it forms the cyclic quadrilateral and the sum of opposite angles will be supplementary. That means we will get the sum of opposite angles equals to 180 degrees. Now moving to the next is another part of the geometry, that is nothing but your trigonometry. So I think most of the students will think that trigonometry is the very toughest topic in your grade 10. But let me tell you that it is the easiest chapter, okay. But what you need to do is if you practice the questions depending upon the methods, because coming to the trigonometry part you are having the different methods to solve the different questions. What we will think is we will just learn one method and one procedure to solve a problem and we will apply the same, but that won't work for the trigonometry. So you have to practice so many questions in the trigonometry to make it easy for you, mostly for grade 10, okay. Yes, So coming to the trigonometry, first of all we are going to find the trigonometric ratios. So how can we get the trigonometric ratio means with the help of a right angled triangle. Okay. So now as you know that we are having a right angle triangle here. So now the side opposite to the right angle will be called as the hypotenuse, and we are going to consider one of the angle as the theta. Now let's take the vertices of the triangle as ABC. So here it is the A. So here it will become A, B and C. Okay. If I am considering my angle C is nothing but theta, then for the theta we can find the trigonometric ratios as we are having the sine theta, which is given by opposite by hypotenuse. Okay. So coming to here it will become opposite by hypotenuse. And moving to the next, cos theta is given by adjacent by hypotenuse. Okay. And tan theta will be given by sin theta by cos, which is nothing but your opposite by hypotenuse by adjacent by hypotenuse. So now hypotenuse will get cancelled and you will get here opposite by adjacent. Okay. Now we are having the inverse of these three basic trigonometric ratios, that is nothing but if I am taking my inverse of the sine, it is given by cosecant theta. Okay, which is nothing but your inverse of the sine theta, which is given as hypotenuse by opposite. And in the same way we are having the inverse of the cos theta also. So that becomes your 1 by cos theta and is represented with the trigonometric ratio secant theta, which is given as hypotenuse by adjacent. Okay. So now in the same way you can take the inverse of the tan theta also. So that becomes your 1 by tan theta and represented by cot theta, which is given by adjacent by opposite. Okay. So now we completed the first part of the trigonometry, that is your trigonometric ratios. After the trigonometric ratios, you are having the trigonometric values. Trigonometric values are nothing but we are going to take the basic angles and the basic trigonometric ratios. That is nothing but here I am going to take the ratio of sine, cos and tan. Because if I know the sine, I can find the cosecant, and if I know the cos, I can find the secant, and for tan we can find the cot. So now the basic angles start with 0, 30, 45, 60 and 90. Okay. So now if you look at here, if I am taking my sine 0 degrees for a triangle, then the value will be equals to 0, and for sine 30 it will be of 1 by 2, and sine 45 it is of 1 by root 2, and for sine 60 root 3 by 2, and sine 90 value will give you 1. Okay. So now the cos values we will get by taking the reverse of the sine. How we will get means, for a triangle if I am considering here theta means what these value will become. These value will become, if you apply the angle sum property, it will become 90 minus theta. Okay. So now cos 90 minus theta will give you the sine theta, that means sine of the angle. So it becomes your 1 and root 3 by 2, 1 by root 2 and 1 by 2 and 0. Now coming to the tan. So tan 0 value will be equals to 0, and coming to the tan 30 will be given by 1 by root 3, and tan 45 will be equals to 1, and tan 60 equals to root 3, and tan 90 will be equals to undefined, or you can use the infinity. So now moving to the next, we are having the trigonometric identities for the trigonometry portion. So coming to the trigonometric identities is nothing but if I am taking any value of the theta and if I place my value of the theta in the identities, then I will get my LHS equals to RHS. So let's see what are those identities. So coming to here, I am saying that the given triangle is the right angle triangle. So right angle triangle means I can apply the Pythagoras theorem. Okay. So let's see what will happen if we apply the Pythagoras theorem. So coming to here, so let's apply the Pythagoras theorem for the right angle triangle. So it will become AB square plus BC square will be equals to AC square. Okay. So now if I am dividing my AC square on both the sides, it will become AB square by AC square plus BC square by AC square, which is equals to AC square by AC square. So now AC square will get cancelled and you will get the value as 1. Now AB by AC, that means opposite by adjacent will give you, opposite by hypotenuse will give you sin theta. So it will become sin square theta plus BC by AC, that means adjacent by hypotenuse will give you cos theta. So it will become cos square theta, which is equals to 1. So this is our first identity. So this is our identity 1, which we are going to use for the trigonometric values. Okay. Now moving to the identity 2. So we can derive the identity 2 with the help of identity 1. So how means, if I am dividing, so let's see what will happen if I am dividing the identity 1 with the sign. Okay. So now it will become sin square theta divided by sin square theta plus cos square theta divided by sin square theta, which is equals to 1 by sin square theta. Okay. Now sin square theta will get cancelled and you will get 1 plus cos by sin will give you cot. So now cos square by sin square will give you cot square theta, which is equals to 1 by sin. 1 by sin is nothing but your cosecant theta. So it will become cosecant square theta. Okay. So this becomes your identity 2. Okay. Let's see what will happen to the identity if we are dividing the cos. If we are dividing with the cos means sin by cos will give you tan. So that will become your tan square theta plus cos by cos will get cancelled. So you will get 1, which is equals to 1 by cos will give you secant. So it will become tan square theta plus 1 equals to secant square theta. So this will be your identity 3. Okay. So now moving to the next, we can find the area of the triangle. That means we can find the area of the triangle with the different formulas. So what are the formulas in order to find the area of the triangle means? Yes. So coming to here, we are having the area of the triangle different formulas, which is given by half into base into height, which we are having in our mensuration. Okay. And another formula you can use, that is the Heron's formula, which is given by root of s into s minus a into s minus b into s minus c. Okay. Now the same area of a triangle can be represented with the help of the trigonometry, and it is given by half of BC into sin A, or you can replace your sides BC with AB and you will get here whatever the values I am taking, I must and should get the remaining value here. Okay. So that means if we are taking the triangle ABC, so this is the A, B and C. Okay. Now whatever the side you are having opposite to your angle A, that becomes your side value of A, and side opposite to the angle B is having the value of B, and the side opposite to the angle C will become your side value of C. Okay. Now if I am taking my only considering the side BC, then I left with the angle A, so that I am going to include in the sin A. Okay. And it can be further can be given as 1 by 2 AC into the sin B, and it can be furtherly 1 by 2 AB into the sin C. Okay. So now whatever the term, that means whatever the angle or the side that is missing from the triangles, that you can include in the sin. Okay. So coming to the trigonometry, you are having your sine and cosine rule, where sine rule is given by A by sin A will be equals to B by sin B equals to C by sin C. Okay. And coming to the cosine rule, so with the help of cosine rule we can find the side values. So that is nothing but A square equals to B square plus C square minus 2BC cos A. Okay. So now these are the important topics that we will help, that will help you to crack the IOQM. That means you can use these methods to, to clear the first stage of your IOQM. So let's discuss some of the problems on the geometry part. So coming to the geometry part, it will be like a scoring subject for you, because out of the 4 subjects, 3 subjects are up to your grade 10. So you can easily, you can practice well in the geometry in order to get good marks in your IOQM. Okay, because coming to the combinatorics and next one is your algebra, which are having your advanced topics. So those who want to prepare for the IOQM and mostly for the grade 8 students, because for grade 8 students all these will be the new topics, but it will be easy for the 9th and 10th. So that's the reason those who want to prepare for the IOQM, you can go for the geometry. Okay, so which will be an easy topic and you can score more from the geometry. So let's see the first question. Coming to the first question, let x and y be the sides of a scalene triangle satisfying the condition x plus 2 delta by x equals to y plus 2 delta by y. So now they gave that we are having the x and y, which are the sides of a triangle, and it is going to satisfy the condition of x plus 2 delta by x, which is equals to y plus 2 delta by y. Now if what is the delta means, delta is representing the area of the triangle. So now if we look at here, they gave the sides of the triangle x equals to 60 and y equals to 63. Now they are asking us to find what is the longest side, length of the longest side. So now represent the given data in the form of a diagram. So first of all, I am going to take my scalene triangle, which is my ABC, and if you observe here, I am taking my BC value as the x, which is equals to 60, and AC value as the 63, which is equals to y. Now I am taking my angle A as the theta. So now take the given condition. What is the given condition here? X plus 2 delta by x, which is equals to y plus 2 delta by y. Okay, so now where delta represents the area, so we can represent the area of a triangle with the formula of using the trigonometry, we can represent it with 1 by 2 into x into y. That means I am taking the two sides, so my angle will become sine theta. Okay, so now place this value in the given equation. So what we will get? X plus 2 into 1 by 2 into x into y sine theta by x, which is equals to y plus 2 into 1 by 2 xy sine theta by y. Okay, now if you observe here, 2 will get cancelled and x will get cancelled, and once again if you observe here, 2 will get cancelled and y will get cancelled. So now coming to the next one, it will become x plus y sine theta will be equals to y plus x sine theta. So now bring the sine terms to the one side and the constant terms to the other side. So it will become, bring your y to the LHS and bring my y sine theta to the RHS. So it will become x minus y equals to x sine theta minus y sine theta. So now from this sine theta, xy sine theta and minus sine y theta, you can take your sine theta common. So here you got x minus y equals to x minus y into sine theta. Okay, on further simplification, so we will get sine theta equals to x minus y by x minus y. Now x minus y will get cancelled and you will get your value as 1. In the trigonometric values where we are having the sine value as the 1, so we are having sine 90 equals to 1. So in the place of 1, I can write my sine 90. So from there we got theta equals to 90 degrees. Okay, now I got my theta equals to 90. That means it will become your right angle triangle. So here you can apply your Pythagoras theorem, which is nothing but your, so here you will get the opposite side is nothing but your BC. So it will become AC square plus AB square will be equals to BC square. So now AC value is nothing but your 63. So 63 square plus 60 square equals to BC square. Okay, now on solving this, we will get BC equals to root of 63 square plus 60 square. Okay, so now from this we will get our BC value as 67. If you simplify it furthermore, then you will get your BC value. Okay, fine. So just comment the answer of the BC in the comment section if on simplifying your root of 63 square plus 60 square. Okay. Yes, moving to the next one. Let ABCD be a unit square Suppose M and N are the points on AB and BC and CD respectively, such that perimeter of your triangle MNC is 2. Okay. So now in order to, that means most of the students will afraid of these questions because they will see that it is the four lines of question. So how can we solve it? Ma'am, we can't solve it. But don't worry, okay. So the simplest method to solve these type of questions is mostly first of all represent whatever the information given in the question in the form of your diagram. Okay. So now if you want to represent the same question in the form of your diagram means first of all what they are saying from the question we have to once again read the question. So now here it is the ABCD is a unit square. So you can take your unit square, right? So now here it is unit square. Unit square in the sense we are having the length of every side as the, that means length of the side of the square will be 1 unit. Okay. So now here AB also will become 1 unit and BC also 1 unit and DC also 1 unit. Okay. After that they are saying that M and N are the points of BC and CD respectively. So here I am having respectively in the sense we are having M on the BC and N on the CD. So now that becomes here M and here it becomes N. Okay. So next they are saying that such that the perimeter of the triangle MCN. So how can we get the triangle MCN? By joining our M with N. Okay. Now they are saying that the perimeter of these triangle is the 2 units. Okay. So now let O be the circumcenter of the triangle MAN. How can we get the triangle MAN? By joining our M with A and N with A. Okay. So now here they are saying that O is the circumcenter of the circle, circumcenter of the circle which is passing through the triangle MAN. Circumcenter is nothing but if you are having a circle that is passing through the vertices M and A, that becomes your circumcircle. Okay. And center of that circle is called as the circumcenter. So now that becomes here, it is the O. Understood? Now coming to here, I am going to join my O with M and O with N. Why? Because you will get to know now. Because they gave that P be the circumcenter of the triangle MON. So they are saying the triangle MON. So I have to join my ON and OM. So now the circumcenter of these triangle will become your P. Okay. So now I have represented whatever the given information into my diagram. Okay. So let's see what will be the diagram will be. So coming to here, we will get the diagram of, the diagrammatic representation of the given information is nothing like this. So here, I don't know what is my BM value. So I am going to consider it as X. They gave that ABCD is the unit square. So now that means our total BC value will be equals to 1. If I am considering my BM equals to X, then I will get my MC equals to 1 minus X. Because this total length is X. Oh sorry, this total length is 1. Okay. And in the same way, I am going to consider my DN value equals to Y. Then my NC value will become 1 minus Y. Okay. Now they are saying that O is the circumcenter. So here it is the O. O is the circumcenter. That means we can have a triangle which is passing through this M, N and A. Okay. Now if I am considering the circle means my MN will become the chord. Understood? Now this chord is going to form an angle in the segment that is nothing but your MAN. Okay. And the same chord is going to form an angle at the center which is nothing but your MON. Using the theorems of the circles, angle at the center is the 2 times of the angle in the segment. So from there we got our MON equals to 2 alpha. Okay. So now let's see how can we solve this question with the help of given information. So first of all, take that perimeter of the triangle they gave as the 2 units. So it will become, so perimeter is nothing but MN plus MC plus NC will be equals to the 2 units. Okay. So from this MN we don't know. So keep it as MN plus MC value, from there we are having 1 minus X. So 1 minus X plus NC value is 1 minus Y which is equals to 2. Okay. So you are having plus 1 which will be nothing but your 2. So I am cancelling the 2 on both the sides. So here it will become MN take your x and y to the other side. So it will become mn equals to x plus y. Okay. So now if you look at here, we can apply here sine alpha. That means we can apply our sine rule for our triangle MAN, and we can apply it for our triangle MON also. Understood? So coming to here, we will get our values. So, Rahim sir, 1 minute break. Okay, so coming to here, we can apply the sine rule for our triangle MAN and for the triangle MON also. Okay. So coming to here, we will get on further simplification as Rahim sir, can I go further? Yes. Okay, so we will end this session for today and we will continue from the next. Okay. So if you are having further any more doubts, you can contact us. So we will solve all these questions in our next session. And if you are having any further more doubts, you can scan this QR, and in order to know more about our courses, you can visit to the nearest center. Okay. That's all for today's class. Thank you for attending, and we will meet in our next session. Yes. A question ఏదో అయ్యింది సో అందుకని భయం వేసింది.